Okay, in this video we're going to talk about functions and invertibility. One of the most conspicuously absent topics from high school curricula. One of the things that they just don't teach or teach properly or seriously in high school, and so people come away not understanding this, and it really, really messes with you in first year when you have to do stuff like invert trigonometric functions like sine and cosine and understand the restrictions on the domain and the codomains. And if that's a word you haven't heard before, I'm not surprised. This is sort of at the heart of the matter. The restrictions on the domains and codomains of those functions, then you really don't have much of a chance of wrapping your mind around this unless you really have a solid understanding of functions and invertibility. And so, like, once and for all, we're just going to take care of this right now. Everyone is going to understand this, and moving forward, those topics are not going to be so tricky. So the first thing, and we have this diagram here, which is we're going to be illustrating everything with these diagrams in this video. In other videos, we'll do a follow-up where we actually draw the graphs, show the graphical approach to this. And we might do a few in here. We'll see if it's going to make things too cluttered. But I have these sets, the set X, which has some numbers in it, and the set Y, which has some numbers in it. In practice, these are probably going to be just R and R, the real numbers and the real numbers, although we're going to see sometimes we have to restrict them. This set X, this is a function here, f, and this set X is called the domain of f. It's where the elements of f are coming from, or where the inputs to f are coming from. And this, and let me write these as we do this, this is the domain, and this Y, if you're tempted to call it the range, it is not. It is the codomain. So the domain is the inputs, and the codomain is not necessarily the outputs, but it's the set to which the outputs belong. The function f is taking in things from this domain set X, and it's spitting things out, and the things that it spits out will be in the codomain set Y. It won't necessarily be all of them, and we're going to get into that shortly. But first of all, what is a function? Down here we have a definition of a function, which I'm going to scroll to. But first, before we do that, we have to see what is a relation. What is a relation? A relation, it can be one set, or I'll say on these two sets. A relation on, as we say, sets X and Y, or between, or if you want to think of it this way, from. It doesn't say from X to Y. So this dynamic kind of notation says it's from X to Y here. What is it? It's a set. Actually, I don't need this colon. What am I doing with that? There we go. From X to Y is a set of ordered pairs. So each one of these is going to have the form little x, little y. And here my definition is creeping in here and ruining the surprise, so I'm gonna kick them down here. Don't read that yet. Don't read that yet. Little x and little y, where little x, you guessed it, is in big X, and little y is in big Y. So it's just a set. R is a relation. If it's a set, this is the set brackets, the curly brackets, it's a set of values x and y. It's a set of all values x and y, where we sometimes say x, r, y, to say that x stands in the r relation to y. You could say y is equal to r of x. Although this is function notation, and we're going to see presently that not all relations are functions. But so this one is unofficial. This is the official one. This is sort of unofficial. But let's for instance look at a relation on these sets. I could say R is equal to the ordered pairs x1, y1, x1 and y1, x2 and y2. Let me move this over so I can have some more space. Say x2, y3, and say x4, y1, say, like that. That seems like a nice relation. This is a relation. It's a set of ordered pairs, right? There's a first one, which is on the left, and a second one, which is on the right. The first one comes from x, the second one comes from y. That's a relation. This is not a function, though, and it's a function for two reasons. The only two reasons that a thing cannot be a function. And to understand that, we're going to read the definition. Actually, you know what? Let's read the definition first. What is a function? And now this guy can come back up to where he's at the top of the page. What is a function? Well, a function is a relation. So it's a set of ordered pairs. It's going to be of this form. But and so again, from x to y, here we're thinking about this. But it's a relation that maps every element of its domain to exactly one element of its codomain. And so I'm going to underline these and highlight them. These are the two important sort of operative words here. It sends every element of its domain to exactly one element of its codomain. So the every is pretty clear, and this makes it clear that functions are special kinds of relations. Every function is a relation. By definition, it's a relation, but not every relation is a function. What does it do? It sends every element of the domain to exactly one element of the codomain. Well, every is pretty clear. Every makes it pretty clear why this is not a function. Which elements of the domain did it send places? It sent x1, x2, x3, and x4. It sent these somewhere, but it missed x5 and x6. These people didn't get sent anywhere. And the exactly one element of the domain, what does that mean? This is a little bit more subtle. Well, it means that, and you might remember something called the vertical line test from high school, and we'll see what that means when we get into graphing these things. It means that it can't send anything to the same to two different places, rather. So in this case, what are we going to do? Maybe green. In this case, x1 got sent to y1, x2 got sent to y2, x2 also got sent to y3, and x4. Oh, it didn't map x3 anywhere. I jumped the gun. It's even worse, not a function. It's even more badly not a function. And even more badly speaking, x4 got sent to y1. Okay. So, and I did this specifically to illustrate that the problem, so we can see that x2 gets sent to y2 and y3. This is what makes it not a function, right? It sends the same thing to two places. I took pains to, not that it was particularly painful, but I was very particular about sending x1 and x4 to the same place. It's fine to send two things to the same place. You just can't send one thing to two places. Although this function, even if it weren't for x2 going to two different places, this wouldn't be invertible because of this, and we're going to talk about that shortly. But the idea is that functions, they can send everything to the same place if they want. Those are constant functions. They can send two or more things to the same place. They just can't send anything to two places. I always tell high school students, think about this as if you need a way to remember it, because it seems abstract at first, and then it gets easier to it becomes intuitive as you use it. But initially, if you want to think of this as functions being like travel agencies, a bunch of people come and they want to go on vacation, and if you're a good travel agency, you're going to send them all somewhere. You can send several people to the same place, but you can't send the same person to two places at once, right? You can't, if you send one of your customers to two countries at the same time, they're probably not going to be very happy with you. And also, if you forget to send someone someplace anywhere, somebody doesn't get sent anywhere, then you're also not a very good travel agency. Not quite as bad as if you send a guy to two different places at the same time, but you're still not very good travel agency. So that's a way to think about this, or to remember this. So this is what a function is, and you might be thinking, why are we spending so much time on this? And the reason is that when we talk about invertibility, what we mean is, I can take the inverse relation of any relation. What is that? I flip the x and y coordinates. So with this, and let me maybe squish this a little bit down here to do this, and maybe this can come down here to make it a bit less cramped.